Hey guys, welcome back. Let's do cheapest flights within K-stops. So there's an n cities connected by some number of flights. You're given an array of flights where flights of I equals from to price. Indicates that there's a flight from I to I, price I. Given three integers, source, destination K, return the cheapest price from source destination with at most K-stops. If there is no such route, return -1. Alright, so here we're given this graph. There's 4 cities. Flights are here. It's directed. We're trying to get from 0 to 3. And the constraint is at most K-stops. So there's 2 paths to get from 0 to 3. One like this, one like this. This path is cheaper, but it contains 2 stops because 1 and 2 count as 2 stops. So we can't go down that path. So the only path that we can go down is this path, and that's 700. Alright, so first I'm going to create an adjacency list and represent this flights as a graph. So I'm going to do for u vw in flights adjacent list of u dot append, and since I'm doing modified dextras, I'm gonna put the weight first, destination. This visited hash map will map, let's see, what will it map? It will map the node and the number of stops to the cost. So each state is going to be represented as this, and as we're traversing down, each node, we had to check whether we got to that state with a cheaper cost, and also if it's within K-stops. So here we'll initialize our queue for our min heap, or not min heap, for our dextras. So it's gonna be like this. So first would be the weight. The second value would be the node. So we're gonna put source in there. Third value would be the number of stops. Now I'm gonna do my dextras. I'll pop the first node. I'll call it cur weight, cur node, num stops. Pop Q. So Q is going to represent a min heap, since we want the cheapest path. So like, let's pretend like this 3, there's like many different ways to get to this 3, right? And we find that there's like 2 ways with the same number of stops where we get 2 different costs. We have to get the cost that's cheaper. So that's why we want to map it as a tuple which contains the node and the number of stops. So there can be many ways to get to this node, but we want the cheapest cost, so that's why we want to override it whenever we find a cheaper cost with this state. So base case would be if the cur node, if we reach the destination, we just return that weight. And here we're going to do the validation check. So if num stops is greater than k, then we're trying to continue. Now that we know it's valid, as in it's within K-stops, we can iterate through our neighbors. So for weight 1, neighbor in adjacent list of that current node. So the new weight equals weight 1 plus cur weight. And I'll create a new state, which will be, let's see, it's going to be the neighbor, number of stops, plus 1. And now we want to update our visited hash map. So if that new state not in visited, then we want to initialize it. So visited of the new state equals the new weight. We also want to override our new weight if it's less than the current state of that visited. So or new weight is less than visited of the new state. Then we want to do, then we want to override like this. And then we have to append, or append to our heap. So heap q dot heap push q. In here, I'm gonna put first value, which is the weight. So new weight would go here. The node would be the neighbor, and then the number of stops would be just num stops plus 1. Okay, so if num stops, if I start at 0, I'm gonna pop it. It's not greater than k. Go through its neighbors. I'm gonna put this new state in here. Num stops plus 1. Okay, so here num stops would be 1. And that doesn't make sense because this counts as a stop. So when I'm at 3, I want the num stops to be 1. So here, I'm just gonna add 1 to here. Yeah, so I wouldn't update num stops like this. I would update the k. And from here, I know that I would reach the destination. If not, then I just return -1. Okay, what, 400. Oh, this would be just num stops. Wait, no, this should be num stops plus 1. If new state not invisited, or new weight is less than visited new state. Visited new state plus new weight. Keep q dot heap push q new weight. Neighbor num stops plus 1. So oh, okay. I guess I don't need plus 1 then. Why do I not need plus 1? Because I thought if I start at 0, pop this would be 1. 100, 1, 1. I'll pop this, go to 3, this would be 2. Oh, because I'm checking this before this. Okay. So, okay, yeah, that makes sense. Alright.